the Accura Easycut 92. It's a 36-inch guillotine. We also have the Accura Easycut 115, which is a 45-inch guillotine, and the Easycut 137, which is a 54-inch guillotine. Across the whole range, we have common features. We have hard chrome-plated tables, center table, hard chrome-plated side tables, and air tables. Now the air tables do not have individual hoses through the nozzles. What it does have is an air chamber here, an air chamber here, and an air chamber here. And if you look underneath, you'll find that there's only one hose going through each air chamber on the right, in the center, and on the left. So that the air pressure from each nozzle is exactly the same wherever you go. It's unlike the old guillotines where you have the hoses for each individual nozzles, thereby creating problems in pressure if one is clogged or one hose has come off or something like that. So in this case, you have exactly the same pressure. Aside from the hard chrome-plated center table, side table, we also have hard chrome-plated side plates, front and back. We also have hard chrome-plated back tables here, and hard chrome-plated side plates on all the sides. It makes it easier for the operator to clean. Even if you have dirty fingers, you won't stain it. Unlike if you had a painted surface like this, then you will have the chances of stains. Now the main difference between this guillotine with the other guillotines is that there is no center slot. With other guillotines, you will have a center slot with a conveyor belt going through it. The problem with that is, number one, you have to replace the belts. Number two, sometimes paper gets in between the slots. And most importantly, without the center slot, you have one integral piece of table, which will not weaken the structure of the table. Now, if you'll notice, the back gauge is a very heavy-duty, very sturdy design, even if it is for a 36-inch machine. Most other guillotines from the past will have just about half the size of this. This particular guillotine, you'll notice, has a back gauge which is really heavy-duty and held on both sides with a linear bearing. Okay, if you care to have a look underneath, you'll find that it has linear bearings on both sides, on this side and on the other side as well. In addition to the linear bearings, you also have lead screw, which has a recirculating ball bearing inside. So the lead screw has a round thread. Okay, it has a round thread because the balls go around it inside the recirculating ball bearing there. Okay. The good thing about having a recirculating ball bearing lead screw is that it requires very low maintenance. There is no direct contact between the lead screw and the bush that moves the back gauge forward and backward. So after many years of operation, all you have to replace are the balls. Now, that accounts for the high accuracy of the back gauge and also its maintenance of parallelism through many years. So it is able to maintain the squareness and the parallelism. To illustrate, let's go through a programming sequence which is to equally divide this pile of paper into narrow strips of 0.5 millimeter. So you press equal divide, and then you divide it into 960 pieces. through an equal divide sequence here, cutting 430 into narrow strips of 0.5 millimeters or half a millimeter. And we do that by pressing the equal divide button by 860. So that gives you half a millimeter, 0.5, and it's asking you to confirm whether they have the right, whether it has the right figure. And then you confirm, and it's going to ask you, is this the figure that you want me to go to? And you say confirm, and then you will hear that the back gauge has gone to that target value, and this is the actual value. So you try and cut. Okay, and it's going to advance to the next size, which is 429, meaning it has advanced by another half a millimeter here, 428.5. And this is the target, this is the actual value. This is the target, this is the actual value. So I am now moving by half a millimeter per cut. Okay, let's have a few more cuts and then see the results. So now I'm taking this strands and I'm hitting it against the table, and even if you look closely, you don't find any paper dust. And even if I do it on the other side, you find no paper dust, which means to say that and there are no strands falling off from both sides. No strands are falling off. This means that each strand is complete. Okay, it's one whole strand. There are no broken strands inside. So I can take out randomly any strand, and you will see that it's all complete strands. Any strand I take out, these are all complete strands. There are no breaks in the strand. Okay? This shows you that each strand is parallel, because if there was any skew or if it was not parallel, then there will be broken strands. But this is completely parallel, so we can see that there is no broken strand. And you can also check this way. You can see that each strand is perfectly sized uniformly, consistently, with no variation in thickness. So this proves that the machine is perfectly cutting square and parallel. One of the most important features of the machine, which distinguishes it from other guillotines, is the fact that we are using conventional electrical components and no PC boards and no computer cards. So if you care to look there, we have opened our electrical control panel, the control and instrumentation board, and you will see that we are using mostly conventional electrical components, which are standard off-the-shelf parts, which can be bought from any electrical store. You can see that we have circuit breakers, timers, rectifiers, transformers, magnetic contactors, relays. These are standard off-the-shelf parts which can be bought from almost any electrical supply store. Now that takes away the headaches of using guillotines which use a lot of PC boards and computer cards, some of which should cost as much as 1,500 euros or about $2,500 depending on the exchange rate. Now with this machine, you won't have that headache. The second most important feature is that here we are using an ordinary keyboard to enter the data. Now, as you understand, of course, most guillotine operators are very strong people. And strong people normally, of course, will have a very firm touch. So if they have a firm touch and they're using a touchscreen LCD, then one particular part of that screen will wear out ahead of the others. Usually, it's the lower right-hand corner which says run, cut, or go. In this case, with our design, if you have a particular key that is used more often than the rest, for instance, we use this more often or this key more often, you only have to replace this key or this key for a few dollars. So you won't have to replace the whole keypad, you won't have to replace the entire touchscreen LCD. And if you do have to come to the point that you have to replace this screen, then you just go to the nearest computer store, possibly Office Depot or Staples or CompUSA or Circuit City, to buy this LCD. This is a standard off-PC LCD as compared to the LCD touchscreen used by the more expensive guillotines. They would be costing something like about 3,500 euros upwards. So that would be something like about $5,000 depending on exchange rate. With this, it's just a matter of going to the nearest computer store, buy one, plug and play USB. So it takes out the headache of sourcing the LCD screen and also the pocket ache of buying a very expensive LCD touchscreen.